in the case of fine cracks easily as compared to the high viscosity epoxies. Now the materials of high viscosities can be effectively used for surface coatings or wider cracks. So if the cracks are very much wider and we have the epoxy material with high viscosity, it can be applied. But in the case of fine cracks, the epoxy material has to be of the low viscosity. So this is also one of the techniques called the epoxy injection technique, which can be applied for retrofitting concrete structures. Now we will focus on a very interesting technique, the technique called base isolation. Now what does it mean? What exactly is base isolation? Now as a civil engineer, we all know we are studying the different parts of a building. Basically we divide a particular building into two parts, the substructure and the superstructure. And this particular technique of base isolation, it is based on separating the superstructure with the substructure. As it is written here also, this technique is based on separating the foundation, which I call the substructure, and the superstructure by introducing low stiffness bearings or a flexible layer. Now what does this mean? It will be more clear from the diagram, but just keep in mind that base isolation technique, the main objective behind this technique is to separate the substructure and superstructure by providing a mediator or a media in between, and that media is the bearing, the low stiffness bearings. And whenever earthquake comes, the seismic waves or the earthquake waves are transferring from the substructure to the superstructure. Those are bear by that particular bearing and is not transferred to the superstructure. Very simple. In the case of our bikes, in our automobiles, in cars, we have shock absorbers. So the basic purpose behind those shock absorbers is to resist the shock, so that shock may not transfer to the person sitting inside the car. The same is the case here of the base isolation technique. The earthquake waves are just damped at that level of the bearing, and it remains in the substructure and are not transferred to the superstructure. So this is a very much most powerful tool in the seismology pertaining to the passive structural vibration control technology. We are basically controlling the vibrations here with this technique. And after the 2001 Bhuj earthquake, most of the hospitals, most of the buildings, especially in Gujarat in India, those are applying this particular technique very effectively, so that the earthquakes can be effectively phased by those buildings whenever earthquakes are phased in that particular area. So all the historical monuments which are very precious for us, the hospitals, the commercial buildings, the public buildings, these are provided with this base isolation technique to keep them safe against earthquakes. Look at the diagram, you will get more clear idea. Now this is the national ground level and foundation part is already casted here. This is showing the base isolator. These black colors bearings, these are showing this is actually a foundation of a very heavy structure of some electrical fitting, it's look like, and this superstructure part is isolated from this foundation part by providing these base isolators. So you will get more clear idea from one or more diagrams. Here you will have a look on this particular diagram. It's a more close look, In this diagram, you can see the low stiffness bearing here. Two bearings are provided here and two here. So this is the foundation part, which I am calling the substructure part, and above it we have superstructure part. So just to bear the earthquake waves, these bearings are playing very important roles. So this whole assembly is called base isolator. Repeating it once again, this whole assembly of low stiffness bearing is called base isolator. This is once again a diagram showing a lot of base isolators: 1, 2, 3, 4, 5, and many more. So as you can see, this is the foundation of any building. It's under construction, and we have to construct a superstructure over it. It's look like as it is in the hilly area. So these base isolators are provided initially, and the superstructure, when it is casted over it, so this particular building is comparatively very much safe as far as earthquakes are concerned. So base isolation technique is, once again I should say, a very important technique which has been effectively applied in the west of India, and now it's very common all over India, since the northern part is coming under zone 4, so it's highly seismic. So it's very good for the structural engineers also to provide this base isolation technique to keep all the public buildings safe, so that we can prevent a lot of lives, a lot of property during earthquakes. Coming to the last technique of retrofitting of concrete buildings by external bracing. Suppose we have a old structure. We will take an example of an old parking garage. You will see how we do the external bracing here. But in this technique, what we actually do, we are providing the confinement, we are confining it with the steel sections, and this is the best solution whenever some immediate and urgent retrofitting is required. Repeating it once again, the confinement with the steel sections, it is the best solution whenever immediate and urgent retrofitting is required. Taking an example of external bracing of a reinforced parking garage. Look at this. Now this is a parking garage, and external bracing of an existing reinforced concrete parking garage is done here. Pleasing use of detail with the waste effect. As you can see, this is a waste part. It's giving a pleasing looks here. So it's a pleasing use of detail here with the waste effect. Then integrated bench in the base is provided here. This is a bench. Once again, it is providing strength, and pedestrians are protected from the collision with the bench by railings. As you can see, these are the shops and these are the exits of the shops. So if some pedestrians are just passing here, so they may not get any problem with this bench, so it is provided with this particular railing here. So by providing this waste part, this bench part, and this particular railing, this existing reinforced concrete parking garage is retrofitted. So these combiningly are providing extra strength, good looks to this old building, to this parking garage, and now the life of this particular parking garage has increased to many more years. So this may be a technique which we can apply it on different conditions. It is not necessary that such bracing is done on these particular occasions also. Whenever there are some spaces or places where we are facing such type of situations, we can provide or improvise our ideas to use different type of steel structures, bracings, and wastes and benches and many more things, so that we can retrofit the old buildings. So these are some of the retrofitting techniques. So I'm very much near to my ending of this session. So just recalling or refreshing what we have studied in these techniques. Basically, I've discussed 7 of the techniques in the case of concrete structures. Retrofitting of RCC structures can be done by one of the following methods, which we have discussed one by one: by providing extra reinforcement, by the process of casing, which I also call the jacketing. Extra reinforcement case, we have seen the beam part and a shear wall or the foundation part, whereas in the case of casing or jacketing, this is applied to the column part, the vertical casing. Then we have seen the 2 type of plates: strengthening by FRP plates and steel plates. Steel plates are heavier, bulkier than FRP plates. FRP is fiber reinforced plastics, which is again very non-corrosive, light in weight, so it can be effectively applied to the beams. How it is applied? It is just bonded or glued with the help of different epoxies or the chemicals available in the market. The same is the case of steel plates also, but in the narrow areas it's not viable. It's not possible to provide steel plates in the narrow regions, but steel plates are also glued with the help of epoxies only. Then we have seen the epoxy injection technique. Now these are the techniques in which the minor cracks are just filled up with the low viscosity epoxies, and the major cracks, the wider cracks, are retrofitted, or these are filled up with the high viscosity epoxies. Then we have seen the base isolation technique, very important one. Regarding, I should say that the basic criteria which is working here in base isolation is we are just isolating the substructure, the foundation part with the superstructure by providing in between the low stiffness bearings in between, so that the seismic waves cannot be transferred from the base to the superstructure, and we can prevent many lives, many property with the help of this base isolation technique. And the last technique which we have seen, it is the external bracing by using different steel sections, the waste part, the bracings, the railings. Today in our session we have seen the case of a parking garage outside the shops, how we have effectively done the retrofitting of a parking garage. So these are the 7 techniques which I have discussed today, and in overall the conclusion of this today's lecture is that what exactly is the retrofitting? The art of the modification, or it is an art of providing extra strength. Its need, we have seen what is the need of retrofitting. Then what are the different objectives of retrofitting? What is the objective behind retrofitting? Then the 6 or 7 steps which are showing that how we do the structural evaluation of retrofitting, how we select different methods and then come to the one method. And finally, as I have just told you, we discussed 7 different methods how to do the retrofitting of concrete structures. So this is all regarding in this session of retrofitting of concrete structures. Thank you very much.